And we're back to the second exercise of the day. We're going to try to solve a triangle. Even though I don't see a picture of one, we're going to have to draw one. What we're given is 3 side lengths. So I'm going to draw a triangle. We'll mark A and B and C. We'll mark our vertices. The side length A goes across. Side length B goes across. That's our longest side. Side length C is the side length that's in the middle. Okay. So here's a hint. Always calculate the angle across from the blank side length first to avoid errors. Alright, so here's the trick. You might be able to understand why, but I'm not going to tell you right away. Always calculate the angle across from the longest side first. This might have some reason to it, and it's going to help us to avoid some errors. Our longest side length is side B. So we're going to find the value of angle B first. What we're going to do is we're going to set up our law of cosines because I don't have an angle across from any of these side lengths, or else we'd be using the law of sines. Part of today's lesson will be how to differentiate from when you use the law of cosines or the law of sines. Right now we're going to start off with the law of sines, but once we find this angle, then we might be able to switch to the law of sines, and watch out for those ambiguous cases if we do decide to switch. So here goes. What I want to do is set this up. So I'm going to do b squared equals a squared plus c squared minus 2ac cosine b. This is the value, or this is the formula that I want to find. I want to find the value of the angle for b. So if we're finding angle b, that angle is on the right, which means its side length is all the way across the equation on the left. Start plugging in these values. 27 squared equals a squared, which is 12. 12 squared, or actually a is 12 and a squared would be 144. Kind of misspoke there. Hope you forgive me. I'm doing the best that we can. Alright, we're solving for b, which means I need everything moved. These are constants. This is a coefficient. So I'm going to square this, subtract that, divide by this, and take a cosine inverse. Easier said than done. I don't need to do this all in one step. 27 squared. Technically, I don't think the parentheses are necessary, although I always love to use them when I'm plugging things in. We're going to subtract these constants from both sides. Hit enter. Then I'm going to divide by a bunch of terms. So I'm going to group all this together. So I want to divide by negative 2 times 12 times 20. Close that parenthesis. This is going to tell us the cosine inverse. So the approximation for that is what I'm going to write down, although when I go to calculate this, I'm going to use the exact value. I want to take the cosine inverse of this negative number. Now cosine is negative in second quadrant, so I expect this to be a obtuse angle. So let's do the second cosine or cosine inverse. Let's use the full answer. So using that trick that I talk about often, we're going to take the cosine inverse. We get this obtuse angle. It's approximately 112.6. We're going to say 70. So that means the measure of angle B is approximately 112.670 degrees. Okay, here comes the reasoning for finding this largest angle first. No matter what we do when we try to find the law of sines, let's say we're trying to find the measure of angle A. We have this, and we want to use this. We have a long side, a short side, and an angle. I don't worry about that. Let's say I was measuring or trying to find the measure of angle C. I would use this side, this angle. That's long side, short side, and angle. This is not the ambiguous case we learned about last week. So the reason we're using the longest side when we can choose is we don't have an ambiguous case for the law of sines. I can use the law of sines now. Unlike the first exercise, I can now use the law of sines to solve my triangle. I am going to do, I guess we'll go in order. Let's do angle C next. So I'll do the sine of angle C divided by 20 is equal to the sine of that answer that I found in my calculator divided by 27. So I'm going to cross multiply, divide, and take a sine inverse. So let's do this. cross multiply my two numbers, so 20, sine, and I want to use the full answer, second negative sign, close it, divided by 27. Hit enter. This is going to equal the sine of angle C. I don't want to know what the sine of that angle is, I want to know what the angle is, so I need to use the second inverse, so sine inverse. Sine inverse, second answer, close it up. This gives me that the measure of angle C is approximately 43.119 degrees. Now, because I'm using a sine inverse, it could also have a supplement that has the same ratio. But the problem is the supplement of this is about 136 degrees, give or take 0.8 of a degree. And if I add that to this one, I've already busted the 180 limit for my triangle. That's why I know this answer is the one and only answer. There's no ambiguous case here. So now what? Now I know two of the three angles. Guess what I'm going to do? Triangles always have 180 degrees inside their three angles. So I'm going to add that. So I'm going to do 180. I'm going to do minus this answer, and I'm going to minus 112.6696099 because that input was right there. Hit enter. And my last available angle is approximately 24.212 degrees. So this solves the triangle. There's only one case. I had found all three of my angles when all three side lengths are given. That's really how we use our law of cosines. So we start with law of cosines. We might be able to switch to law of sines, and then your triangle sum theorem that all three angles add up to be 180. So it gets like easier. The process gets easier the more you work with it. But also we have to be aware of your ambiguous cases. The hint says we're going to find the longest side first when we're given side, side, side. This way we don't have an ambiguous case no matter which setup we do. Let's move on to our next video.